Yeah, good evening. This is my presentation for the project. The project is to classify waste products using transfer learning. So this is the content of the work I've done on the project. So introduction, in this project I will classify waste products using transfer learning. The project overview. EcoClean currently lacks an efficient and scalable method to automate waste sorting process. The manual sorting of waste is not only labor intensive but also prone to errors, leading to contamination of recyclable materials. The goal of this project is to leverage machine learning and computer vision to automate the classification of waste products, improving efficiency and reducing contamination rates. The project will use transfer learning with a pre-trained VGG model to classify images. What is the aim of this project? The aim of the project is to develop an automated waste classification model that can accurately differentiate between recyclable and organic waste based on images. By the end of the project, I will have trained, fine-tuned and evaluated a model using transfer learning which can be applied to real-world waste management processes. And the final output will be a pre-trained model that classified waste images into recyclable and organic categories. So the learning objective, the main goal of this project, what I'm going to walk through as I work on this project, is number one, I'm going to apply transfer learning using the VGG system model for image classification. I'm going to prepare and pre-process image data for machine learning tasks. I'm going to fine-tune the pre-trained model to improve classification accuracy, and I will evaluate the model performance using appropriate metrics, and I will visualize the model prediction on the test data. So I list the processes into the sub-tasks that I'm going to be working on, and these are the tasks from task 1 to task 10. Working through these tasks is a clear process to the execution of this this project. Now the setup for this lab, for this project, I will be using the following library. I will be using the NumPy, the scikit-learn, the matplotlib, and the TensorFlow. So from the TensorFlow, I'm going to be using the Keras package from TensorFlow. So this is what is used for this particular project. So the first thing was that I pip installed the various packages, the TensorFlow, the NumPy, the scikit-learn, and the matplotlib, and there is the code for the whole of that. I then imported the required libraries, so the NumPy for mathematical analysis, the OS for the operating system. The OS library enables Python language, the Python programming language, to be able to assess the system itself, because from there we are going to be using the downloaded data set. We have the globe, we have the matplotlib, we have the pyplot, we have the TensorFlow and various packages from TensorFlow and Keras. And the whole of this shows the importation of the whole of these packages that are used for the execution of this project. So the task 1 was the task of creating the version of the TensorFlow. So we see that the version of the TensorFlow used here was 2.17.0. So this shows an error here because my runtime had expired, so I had to rerun everything from the beginning. So this as I said before, this code is pip installing the packages that I used for the project. So as I said before, the whole of this delay, so the runtime expired and I had to rerun them. So because of time, I should proceed with the presentation of the process of the project, as the whole of this code has been run before this particular time and the outputs have been detailed out. Yeah, now I went forward to importing the dataset. So as you can see here, the dataset that was used is the waste classification dataset. So I trained an algorithm on these images to train or to predict labels for the images. So 1 is for recyclable images, while 0 is for organic images. So when a prediction shows 1, it means this is an organic image, and when it a recyclable image, and when it shows 0, it means this is an organic image. So these lines of code actually imports the data. So the data was downloaded in zip file, so we imported the zip we imported the zip file folder. So this is a package that actually unlocks the dataset from the zip file, and from here we had the dataset here. So as you can see here, they say 100% finish extracting. Then let's look at some configurations options for this project. So the batch size was set to 32. The number of classes is set to 2. The 2 here meaning the recyclable and the organic. And here we are going to use 20% of the data for the validation process. So we have 2 labels, as we said before, the O for the organic and the R for the recyclable. So from here, we loaded this data set to our system, and from here we are now using the image generator. So this image generator, what it actually does is that it performs some sort of data augmentation on the trained data, and also it normalizes the data set. As you can see, we see rescale here. So 1:255, it normalizes this data to that, and the other function here performs some sort of augmentation for the data set. So thereafter we have the validation data set. So the only thing that was done here was the rescaling. So there was nothing like augmentation there. And we have so from there we see that we had in the trained data set we had a total number of 800 images belonging to 2 classes, which are the organic and the recyclable classes. The same thing with the validation data set. So we had a data set of 200 images there belonging to 2 classes. And also when we now come to the test, also we have 200 images there belonging to 2 classes. So this line of code helps us to print the length of the train generator. As you can see, the length is 25 here. Now let's come, so this is a display of the images in the dataset. As you can see, this looks like this is just an image from the images in the dataset, and you can see the labels here, they are all O, meaning they are organic. These are organic waste. Now thereafter we instantiated the pre-trained model that we are to use for this project. And as I said before, the pre-trained model for this project is the VGG16 pre-trained model. So it's a model, it's a computer vision model that is used as a pre-trained model when we have a limited data set. And as we see here, the data set that we had here is just about 800. So they are very limited data, because deep learning models actually are trained on large and a vast amount of data. So having a limited amount of data here actually has a lot of impact on the performance of the model. So thus we have to seek the help of a pre-trained model so that we have a very functional system. Now from here, the whole of this code are working on the pre-trained model. So we are trying to fit in our model, meaning we are trying to fit in the model for the data into the pre-trained model. So this is the summary of the model. So after we have infused our data into the pre-trained model, so this is the summary. So from here we compile the model. So the loss that we use here is the binary cross entropy. The optimizer is the RMS prop, while the learning rate is 0.0001, and the metrics that we use here for judgment is the accuracy. So from here we schedule the learning rate. As you can see, from tensorflow.class.callback we import a learning rate scheduler. So what this does is to regulate the learning rate so that it conforms with the model. So here we fit and train the model. So after the training of the model, we have a loss. As we can see, the loss is constantly decreasing, both for the training data and the validation data, which shows that we are pretty doing well. And here there's the accuracy curve, and the accuracy is constantly increasing for the training and the validation data set. So this the constant increase shows our model is doing pretty well. Now it comes to the fine-tuning of this model. So what we did here was that we unfreezed one layer from the base model and we trained the model again. So after this retraining of the model, we had another loss for training and the validation, meaning for the fine-tuned model. Now, as we can see, it's still fantastic, and we have the accuracy curve for that again. Now we evaluate the model based on the test data. So what we do here is that we load the model, the saved model, and we load the test images. We make prediction for both models. We convert prediction into class labels, and we print the classification reports. So this is what was basically done with those lines of code, and we can say we have an accuracy of approximately 19%. We have a precision of 19, a recall of 88, and FWA score. So this whole of this data shows that the model is doing perfectly well. And finally, so these are some of the predictions that we have for the model. So this is my humble presentation. I'm very grateful for the opportunity to participate in this program. Thank you very much. Goodbye.